Hello and welcome to our live coverage of the Hayabusa 2 snatch and grab of gravel and rocks and surface material, probably less than a gram, off the surface of the asteroid Ryugu. We are currently waiting for this YouTube stream to go live, and I am here to bring it all to you, to answer your questions, and to help you understand everything that's going on. And it looks like we are getting going. So this is a JAXA-sponsored mission. And I seem to be having some audio issues.
Let me explain about the situation of the Explorer. RCS 120%. The parameter registration has been completed. RF OHC camera power 1. Projectile safety lock has been lifted. And the automatic sequence has been started. Altitude has reached 32 meters. And we're ready to start the fight. That is all. Thank you.
Thank you once again for follow. So no one quite knows what to anticipate. JAXA is one of the new outstanding partners among all of those nations that are live streaming their mission briefings. We are here learning with you, and this video is summing up the issues they faced. So they initially planned to land Hayabusa 2 on Ryugu back in October. However, they were foiled by the realization that this little asteroid, less than a kilometer across, is actually covered in boulders that make it hard for them to find the kinds of soil samples they want. Back in August, they changed how they orbit the world to measure gravity, and they've done a number of different passes close to the surface to figure out exactly where they want to land, not just this time, but all 3 different times. So they'll be diving down to the surface and doing a new snapshot. This mission has also carried a number of launches. These little robotic landers that could easily fit in a hat are spring-loaded in ways that allow them to fly meters upon meters across the surface, sending back those dramatic images that we inherit today. They still have one more rover in reserve before we can see go down. There are, of course, 3D plans to print your own version of the Ryugu asteroid. There's the Minerva lander going in, or mascot rather.
今回の大きな目的はターゲットマップを分離して
So they run these rehearsals using simulated data. Various problems that have to be solved in real time. They don't tell the people in the simulated mission control exactly what to expect, thus making this a real dress rehearsal. It prepares them for the stresses of a day like today. But they actually had to make real-time corrections to what they were planning. The descent towards the surface of Ryugu actually started roughly 5 hours later than planned, as they considered, would today really be the day for that landing? Well, they did make their decision, and in order to land at the intended time, and here you can see something went wrong during the practice, in order to make the intended landing that they intended today, they had to change the velocity at which they would touch down. So that was the shot out of the laser ranging finder. This is beautifully done video. Particularly amazing about this project is this is their second mission to go out and explore asteroids. Hayabusa 1, of course, was the first one to do this. And Japan has made this great leap out to asteroids bypassing Earth's moon. Moon has only been landed on by the US, Russia, and China, with, in the coming weeks.
Good morning. This is the Hayabusa 2 touchdown live. We'd like to thank you very much to our audience for being here early. For 2 hours and a half, Hayabusa 2 developments will be reported, and the control room situation and the changes there will be communicated to you. I'll be moderating this program. I'm science communicator. My name is Yuko Okayama. And from the project member team, we have 3 of them here, and we'll be reporting, all of us will be reporting to you. A supervisor, Mr. Hosoda, and I'll be reporting from the control room after this as the special reporter. System impact device development person. From the development, from the initial operation and the impact device was my responsibility. My name is Imamura. ion engine overseas station responsible person, Mr. Tsukizaki. I was using the NASA California antenna to participating in the operation. It was snowing in California, but the procedure has been completed smoothly. During this program, we'll be accepting questions and messages from the audience. Use the hashtag Haya2_QA or hashtag Haya2_TD to send us your messages and questions. Hayabusa 2 and the mission positioning and what Hayabusa has been done will be briefly explained after this. Mr. Imamura, please. Please use the slide. This is the touchdown operation and a live program of this at JAXA. We're dealing with not only Hayabusa 2, and we've done MMX, solar power cells, Okeanos, and Destiny Caesar Juice. This is what we're contemplating for the future. And this is not just a one-off event. Through a multiple number of projects, we hope to obtain more effective results. And today we will be covering the Hayabusa 2 touchdown. The sizes of the Explorer is 1 meter times 1.6 meters times 1.25 meters. And when the solar paddle is developed and opened up, it's 6 meters. The weight is 609 kilograms at launch. It's a little bit smaller than a car. It's smaller than we imagined. We hope Hayabusa will do a good job. And we'll do a point touchdown, and we'll be talking about the accuracy, and we'll be referring to these figures later on. The objectives are such. The Hayabusa landed on the S-type asteroid Itokawa. Hayabusa 2 will be landing on C-type asteroid Ryugu, which is carbonaceous, and the sample return is the objective. We will clarify the origins and the evolution of the Earth and the ocean and lives by clarifying the mineral water and organic matter interaction. What has been demonstrated in Hayabusa will be maintained to clarify more information. There are lots of C-type asteroids, so there's more of the S-type asteroids. And because it was...
These are carbonaceous and silicon type asteroids. Asteroids come in a variety of different types. It turns out the majority of them aren't heavy in metals. This is an asteroid that in composition is very similar to the asteroid series. So here they're discussing the launch 4 years ago.
And several months ago, and it landed on Ryugu last year, end of June, and presently it's here. And Ryugu will start in November or December. We'll leave Ryugu on the November of December, and all the time it'll be circulating around the sun, accelerating, and it followed this trajectory to land on Ryugu. After it lands on Ryugu, this is the schedule. From July to August, observation is the main mission, and it will descend several times to take images. After September, there'll be a touchdown rehearsal, Minerva 2, 1 separation and operation, and mascot separation operation in October has been successful. And touchdown rehearsal was in October. It went as close as 22.3 meters altitude. On the 23rd of October, we did a third rehearsal, touchdown rehearsal, up to an altitude of 12 meters. And then the solar conjugation was in November and December. The Hayabusa was on the other side of the sun, so we did not operate much. And after that, on the 22nd of February, is now the touchdown. And we plan to reach altitude 0. So you've done many rehearsals, and things have been progressing smoothly up until now. Yes. The rehearsal? We've done much of that. Behind us, we have Mr. Imamura and Mr. Hosoda. That's the studio camera there, the white item there. That's 5 times 11. There are 50 of these boxes, and each of these boxes are related to the special training operation that we have done. It demonstrates the training operations that we have done. The black and red parts show failures, and the orange was where we just about received a passing grade, and it's almost passing. The white and green stickers are successes. So if you look, you see a transition from more failures to more successes. Touchdown is toward the bottom. That's where at the end we were successful. Please point to the box where it was successful. It's not that one, this one. The lower right, the bottom right box. That's where we finally succeeded, and we're where we are today. So you've trained 50 times in the past. So we haven't wasted the 4 years after launch. Could you put the image back on the PC? The touch rehearsal 1 and rehearsal 3 is where we went to altitude of 12 meters. That's October 25th. And the cam head, a camera which is on the bottom side of the Explorer, has been used to take this image. You can see the shadow of the Explorer. The width is 6 meters, as you can see. And we will try to take images this time as well.
You can see in the background of this image all of the boulders that are making this such a difficult approach. They have to figure out how to maneuver the spacecraft so that it doesn't accidentally touch a boulder, doesn't land on a boulder, avoids the boulders altogether. So when the boulders are the same size as your spacecraft, this can be a bit of a challenge. But they have figured it out, they have practiced it, and now they're ready to go. So they began the descent yesterday to bring it from an orbital distance and bringing it closer and closer in. They are now getting ready to discuss the final descent stages with the briefing folks.
So I was a supervisor, so I was speaking in front. So the gate means checkpoint. There are several checkpoints that Hayabusa 2 is expected to go through, and the first one is gate 1. How many are there? There will be 6 in total, including the one at the point of finishing the operation. So project manager is giving words of encouragement. He's wishing for a perfect touchdown. Now, please keep your mental status cool and level-headed, and have your heart hot and with passion. So after this, there was some time spent on research. So after 5 hours delay, the descent was started, and this is when go or no-go decision was made. So the person who's speaking is the flight director, Mr. Saeki, on-site person who's responsible for the whole operation at site. Please review the sheet for each subsystem again. So we're at the starting point, finally. So that was the noon yesterday. And then
kudos to the translators. They're doing this in real time, folks. Translating in real time is amazingly difficult.
Here, there was a downward descent from the top side, and there was acceleration made for Hayabusa 2 toward Ryugu. And there were smiles seen, so that means that progress is being made steadily. Well, there are a lot of things that have caused this 5-hour delay, but people at the site were encouraged, and they just realized that the space is not that easy to deal with.
That's an understatement. Space is hard.
And that was up until noon yesterday. And then this is just a few minutes ago at the final go, no-go decision point. Out of the 6 checkpoints, this was the third one, and this was the D major, the largest one. And the third checkpoint would enable the project to give go to Hayabusa 2. And the project manager said go. And we just leave everything to Hayabusa 2 from this point onward. And there's very little that we can do. We just ask the Hayabusa 2 and wish Hayabusa 2 well. And that was the point of checkpoint 3 that they have passed just minutes ago. And so Hayabusa 2 is now descending toward Ryugu, and we're watching that as we broadcast this. And there will be several windows to split the screen, and what's on the middle is in the control room. The system and the project managers are seen, and on the right top corner at the touchdown, what will be the movements of Hayabusa 2 is shown in this diagram, and if you reference this to see the progress, and then we are going to broadcasting live. And then right corner in the middle is the CG schematic that has been borrowed from Yanagida-san, and then on the beneath that is the actual elevation, 184 meters. This is the 184 meters from which the Hayabusa 2 will directly descend. So at what speed it is moving, several centimeters per second is the velocity currently. And then right bottom corner, you can see us broadcasting and also giving various information as the progress is being made. And please switch over to the camera from the top. And in the control room, there are various types of people working, and who's doing what is what I'm going to explain. Please switch over to the PowerPoint presentation. And here, from this angle, there are several important persons. First is in the middle. Operations supervisor. Right next to him is a commander. SV stands for supervisor, and CMDR stands for commander. And those are the kind of positions that we take often. And supervisors and commanders are controlling the operation progress. And the commands are given to the commanders from the supervisor, and with the direction from supervisor, the commander actually dispatches the actual commands to the Hayabusa 2. And then the project manager behind and right next to the supervisor is FD, the flight director. And the flight director is the person who's responsible for the whole operation on the site, and that he collects all the information and make judgment about what's happening in the Explorer and give necessary instructions. And project manager decides go or no go. And those two persons will not come down to the control room unless there are touchdown operations or mascot deployments. When there are very important operations being made, they will come down to the control room. And then further to the back, AOCS, which may not be so familiar to you. This is an attitude orbit control system, Hayabusa 2 guidance, and how to fly. And all this is under their responsibility. And whether the landing that they had envisioned would be successful is what we are watching. If you lose altitude in the space, what is going to happen? That would mean that it is in trouble. There's communication from the ground, and in the very narrow space of 6 meters, you have to make sure that you will land safely, and everything is being considered. So you point the antenna to the Earth, and solar panel should be directed to the sun to make sure that there's power supply. And with a good control at the destination of 6 meters, you make sure that Explorer would touch down. So this is the crucial role. And how far away are they from the ground, from the Earth? 300 million kilometers. So it takes 40 minutes even for the light to have a return trip. So thank you. Now I will go down to the control room now to keep you updated about what's happening. So I will just leave this studio and go to the control room. Now, this is the control room that you're seeing at the main screen. Everybody is wearing a Hayabusa 2 jacket, and it shows really that people are united. And there's so many people gathered in the control room. Is that quite rare? Well, on an everyday basis, in the operation, there are much fewer people. Supervisor, commander, and a attitude system, at least 3 or 4. Those are the kind of people that we see. But there are several tens of people now. Yes, all the people who are responsible, the whole pieces of equipment of Hayabusa 2 is now being monitored. And there is another room, aside from this control room, where there are people who are analyzing the operation data.
All of the project members are here watching, and there are people watching the YouTube, which are following the development. So it's getting more exciting. Actually, we're running this 24 hours, 3 shifts, 8 hours each. Each shift is 8 hours. So 3 times the number which you see on the screen are actually working. Thank you. Other than the project members, there are logistics and information-related persons behind the scenes who are playing a supportive role. Yes, many people are supporting this endeavor indeed. And so let's go into the reasons why we're doing the asteroid exploration on the touchdown operation. Mr. Imamura will explain. As to why we're doing the exploration, we'll be asking the scientists to explain the details later. But
this is one of those times that you can see the real difference between NASA, which has a fairly significant budget for NASA TV, and JAXA, which is just starting to branch out in doing public broadcasts. The use of PowerPoint presentations is definitely not something that we're used to. Now, what they're explaining right now is why Hayabusa 2 going to Ryugu. Well, this particular asteroid is in an orbit that is not that different from Earth's. It's an Apollo-class asteroid. It has an orbit that takes it out to about 1.6 times the Earth's distance from the Sun. It then comes in, crosses Earth's orbit, goes in a little bit closer to the Sun, and this means, sorry, I apparently can't talk and listen simultaneously today. This particular orbit means that, well, one, it's a bit of a hazard to the planet Earth. While we don't see any time in the immediate future that it's likely to hit us, it is an Earth-crossing asteroid, and those are always something to be watched. But more importantly than that, if it formed where it is currently located now, it is made up of some of the original materials that were used to make up our own planet Earth. This is that leftover bit of cookie dough that splashes out of the bowl onto the counter. It, unlike Earth, didn't go through the oven, didn't get weathered, didn't go through, well, all the things our planet went through. So this is our chance to get up close and personal with an object that may be made of the same materials that made us. Now, asteroids can switch orbits over time. A variety of different things can move them hither and yon. But this is at least a potential. Thank you, Bill Nash. Thank you so much for 4 months of subscription. It is space. Can we light up the chat for Bill Nash and give him a shout out? He's another educational streamer here on Twitch. Now, with the Hayabusa 2 mission going to Ryugu, this is a mission that's taking place at the exact same time that we have OSIRIS-REx at the very similarly shaped but compositionally different Bennu asteroid. And I have heard that many members of the OSIRIS-REx team are, like us, glued to this YouTube stream, watching what is going on as this little spacecraft gets down to that target height. Currently, it's at 180 meters, it looks like, and 180 meters and holding at this point. They are on their way towards the landing site. Now, one of the things that they appear to be talking about is this a wet object or a dry object? And just where did the water here on Earth actually come from? This is one of those great mysteries that we keep thinking we figured out, and it turns out we're wrong. And only through further exploration of asteroids are we going to be able to understand what's going on. It was originally thought that objects, I have no clue what this particular image is. Hold on, I need to listen.
Moons or satellites, Ganymede, for example,
Okay, so they're doing a comparison of the size distribution of objects in our solar system, showing just how much mass and how much water in turn go into each of these things. Our own planet Earth is only, as that shows, about 0.12% water, whereas other objects such as Ganymede, one of the moons of Jupiter, is made of a substantial percentage of water. Part of the reason that we see this difference between what does and doesn't have a water-rich crust is where the object formed. Objects like our own planet that formed snuggled up to our nearby sun, well, that sun in its early days baked us dry. Now, this mission is just one of many different missions that are planned to go to asteroids. Let's take a listen.
A series of missions were looking into the origins of what brought water and organic matter to the Earth, and the asteroid Ryugu and Mars satellite or Mars moons exploration plan is in the offing. That's the MMX. And MMX is the Martian Moon Explorer. That's Mars Moon Exploration project. Yes, that's it. And then asteroid Phaeton and the inter-asteroid cosmic dust. Phaeton is not a word which is familiar to us. There's a twin comet mother entity is Phaeton, and that's Destiny Plus. And then you have the comet Cherenkov-Gerasimenko. Rosetta went to this comet, and lander Philae has been landed. And there's a lot of information about this comet. Rosetta just went there, but Caesar, this is a NASA project, and JAXA will be cooperating. And we would go and obtain a sample and retain it at low temperature. In what way will JAXA cooperate in the Caesar project? One of the key equipments, capsules, will be provided. Hayabusa capsule technology will be applied to the Caesar project. That's right. IFA is the European Research Institute. Institutes all over the world are exploring asteroids and trying to elucidate more about organic matter. When this is brought back to the Earth, state-of-the-art technology will be used to analyze, and we have the people who are analyzing who will be giving you more information. And that's the strength of bringing back samples. And that's the plan with regard to the asteroid exploration and the reasons we're conducting this exploration. And let me now explain about the touchdown. The touchdown spot, that's the Ryugu C-type asteroid L08. That's within the red square that the landing will take place. What do you call this? This is a flat development Mercator method, perhaps. This is the Bravo crater. That's where the landing will take place. The middle is the equator. This is the Bravo crater. That's a fancy name. And then you have Kintaro, Urashima, Momotaro. These are names of craters. These are names related to from fairy tales in Japan. Ryugu also comes from a fairy tale, the Urashima Taro story. How did you come to decide on these names? We've solicited names. We've asked people to offer names, and people from all over the world came up with names, and we've shortlisted these are the names that have been suggested, and the project members decided. I was not a member then, but yes, the project members, I think, decided. I don't remember very well, but I think we made the final decision over a drink or so. Yes, these are all good names. Water and organic matter exploration, because this is what it is. These are names related to water. Bringing back the sample is like bringing back a magic box, which appears in the fairy tale of Urashima Taro. This is a fairy tale familiar to all in Japan. Before that, the asteroid names were numbers, which were very complicated and hard to remember. Project members all remember the code names, 1999JU3.
So, from overseas, there are some names offered based on mythology from overseas, not just from Japan. And this is touchdown operation plan. Around 8:25 in the morning, it is expected to touch down. And with regard to the time, this is what we can confirm, at the time that we can confirm at the ground on the Earth. So one-way trip takes 19 minutes. So actually on the Ryugu, 8:06 is the time for touchdown. And 19 minutes after, on the Earth, we can confirm the touchdown. And then radius is 3 meters. Within the circle of 3 meters in radius, the touchdown should be done. And target markers with the flash, there will be a white light coming out from the target marker. And then right next to that, the touchdown will be made. So is it going to be a mirror? No. If you put a light on it, then it will be the light coming back, not like mirror balls, but the whole sphere will return the light. So the radius is 3 meters, and Hayabusa is 6 meters long. So with the same area, you have to park your car, so to speak. Yes, within this space of 3 meters in radius, if the sampler horn can be placed, then that should be okay. But there is only a margin of error of 3 meters. Yes. And project manager has had a very good analogy, so that will be explained later. And this is the touchdown sites L08E1. There are some bumps, but we have chosen the site which has the fewest bumps.
So those bumps are generally boulders on the surface. It's not entirely clear how you get boulders forming on the surface of the asteroid. One theory is they are actually claved off through the heating and cooling process that the asteroid undergoes. You can see just how difficult it was to find a place big enough for the spacecraft to go in and touch. So this is showing the general alignment between Earth, Sun, and spacecraft. They needed to have this encounter occur at a point in time when we had direct line of sight from the Earth so that we could communicate with the spacecraft, and we also needed things to be illuminated by the sun correctly. So this is giving you a general sense of the different angles involved in going in for this. As she was saying earlier, currently, this asteroid is 19 light minutes away. This means that it takes radio signals 19 minutes to get from Earth to Ryugu, or 19 minutes to get from Ryugu back to Earth. Now, this is a frustrating process that means all the information we get today is going to be delayed by those 19 minutes. So we now see an update coming in on the screen where you can see in the back right where it had showed the rocket was at 180 meters for quite some time. It is now at 64 meters. You can see in the landing plan exactly where they are. So they're in this section on the landing plan right here. And so they're now headed in. So they are starting the touchdown operation sequence. She is getting ready to discuss it. Let me switch over so that you're listening to her.
From last night, from home position of 20 kilometers, it has been descending steadily and with 10 centimeters per second in speed, and at the elevation of 45 meters, the mode will be switched and changed, and then it will touch down and then start to rise again. That's the sequence, and after 45 meters, this is more detailed picture. So this has been the image that was shown on the right top corner on the screen.
So I'm going to take a minute to try and explain this. So as you look at this image, and let me go ahead and embiggen it for you. As you look at this image, you can see that there's a round ball down here in the center. This round ball is their touchdown marker that they've deployed several months ago. This allows them to make sure they know exactly where they are relative to the landing site. So they're going to come in, check their position off of this touchdown marker, tilt their spacecraft over. They're going to switch in the process their antenna from a low gain to a high gain antenna. This allows them to send a different amount of information at a different pace as they go. Now, the reason that they're tilting the spacecraft is they're landing on a slopey surface. So they have to tilt, move, and then come down. Now, once they get down to the surface, they actually have a really clever way of getting material off the surface into their detector. They're firing a small projectile out of their detector cone at the surface, and then they're going to collect the material that gets popped off the surface by that, well, essentially it's like a bullet. So when this occurs, they have the ability to capture up to 10 grams of material. They're expecting to get under a gram in reality, but it's still quite amazing to imagine what all they're capable of. We see that they've now updated their position to 49 meters. Now they're overlapping with their actual modified plan. You can see that when they came down, they were a little further along. And now she's switching over to something else. Let me switch over to her.
It is of a control room. Can you hear me? I guess not. Mr. Hosoda, can you hear us? No, not yet. And there are so many people who are standing in the control room watching the screen. Hosoda speaking. Target marker, whether it has been captured or not, that signal is now coming in, and so everybody is now watching whether the signal has been received. So there is data from telemetry for timeline still there. Mr. Hosoda, can you hear me? Yes. So the data will disappear soon. Yes, we can hear you. Whether the target marker can be seen, the information will come, but Explorer will be tilted for a touchdown shortly, so the signals will disappear. So let's switch over to the video. So Hosoda-san, if something happens, please let us know. Please switch over to the personal computer. So as Mr. Hosoda said, there's a switch over to the attitude for touchdown, and that motion is now being shown in CG. This is at the time of the planning. So touchdown sequence, this red circle portion is the one that it is now being performed. And position is being tilted, and then parallel movement is done, and while watching the target marker, it will be shifted toward that point. And this is the images of ONC camera. The white is the target marker, and this will be the benchmark, and offset is going to be done. And green has a 3-meter radius, and the Explorer is 6 meters long. What do you mean by offset? Well, in Hayabusa 1, it was looking at the target marker in the center, but with this, the target marker is viewed at the edge for landing. So they are going to touch down, or it is going to touch down without address. Mr. Hosoda, what's happening in the control room? Well, the attitude has been changed for the Explorer, so the screen information is gone now. So from now on, we're just going to depend on the speed information, and it seems that things are going smoothly as scheduled. So based on the pre-dispatched command, the Explorer is now moving on its own.
Then let me continue to explain. Back to the PC, please. Initially, we envisaged one touchdown within 100 square meters, and that's now been reduced to 6 meters square. This will be a top pinpoint touchdown using offset, different from the Hayabusa touchdown, which we initially envisaged. This is an analogy by the project manager. Yes, within the target mark, the target marker capture has been confirmed by speed. The target marker has been captured. Hayabusa 2 has captured the target marker, and now finally it started to move in preparation for the touchdown. We're getting very excited. And if you could switch to the PC once again, this is where we are. The target.
So they're currently at this point in the diagram, whoa, there. So they're currently in this part oh, sorry, I lied. They're currently up here. They're moving a lot. So they're currently up here in this top right section. They're now going to be descending down to 6.5 meters. Their orbit started at over 20 kilometers over the surface. These two images show you what that difference is. Now, in the end, they're going to have to go from that over 20 miles up to landing on something the size of a pitcher's mound in a baseball stadium. They have a very small landing region. And so here you see target marker, and they're going to be coming in to land beside the target marker. Let me switch over.
To safety, the Explorer is moving automatically, and if something goes awry, it will abort. And when abort takes place, the safety of the Explorer will be secured, and so we could retry. And the abort designing has been very rigorous to ensure safety of the Explorer. That is all. Thank you. And from here on, we will go more into depth into the science. Mr. Fujimoto and Mr. Watanabe and Mr. Tachibana and Patrick, project members, will turn to you to go into depth about the scientific aspects in detail. So over to you, please.
Their audio seems to have cut out. This is a problem on their end, not in the stream. So currently you see everyone staring up at the monitors. They have just received confirmation that they have made contact with the target marker. That is this blob down here that they laid down on the surface earlier on during the mission. Now that they have captured their target marker, they're going to begin lowering even further towards the surface of the planet. Once they're in the correct position over the target marker, they will tilt their spacecraft. Now, when they tilt the spacecraft...
Good morning. I'm Vice Director of JAXA. My name is Fujimoto. The four of us will be explaining what happens after the sample has been extracted, and international cooperation is another matter we'd like to discuss. We're very excited, and today's event is very much under focus by people at NASA. And the message from NASA is what we'd like to show you first.
I'm Lori Glaze, Acting Director of the Planetary Science Division at NASA headquarters. On behalf of all of NASA, I want to wish the Hayabusa 2 team good luck in the attempt to touch down on Ryugu to retrieve a sample of its regolith. With every one of the spacecraft's achievements, with every piece of data collected and every image beamed down to Earth, and now with the collection of a regolith sample, the Hayabusa 2 team is bringing us closer to answering fundamental questions about the origins of the solar system, about who we are and where we came from. Thank you for all your hard work, and good luck.
So, Lori, good luck to you. Good luck to OSIRIS-REx. When we have both samples from both missions, that's going to maximize the science output for planetary science. So, NASA もです。
OSIRIS-REx is a similar mission to Hayabusa. So they're making maximum efforts, I'm sure, to ensure success. And that we get samples is very important for our community. Mr. Watanabe, for 8 years, you have been a project scientist, leading the scientists. What is your take on what happened this moment? At the JAXA, we have a lot of very competent researchers, engineering members have been very active. And in addition to this, on the domestic scene and overseas, we have had cooperation from the experts. And we have a very good collaboration, as a result of which we can look forward to operational success, and we've obtained results, and we've worked very hard, and some had work related to the universities. In addition to this, we've done this, and we're very happy that as a result of this, we're witnessing this wonderful event. There was some news earlier that about the target marker. 180,000 people have their names on the target marker, and so the target marker is supported by various persons. That's very symbolic. What is your view on this? 180,000 people are involved, and so I hope that the touchdown will be a success in view of this effort. With regard to sample return, I think it 4.5 billion years to extract the sample. Organic matter, water, which has come to the Earth through an asteroid, was the origin of life. And as a result, human beings evolved, and these human beings are now going to Ryugu with a target marker to return a sample. So this is a 4.5 billion year sample return, and after 2020 we'll have a sample return. So there's this dual aspect. The present planet science and the direction which is headed to has been just referred to. Before the Explorer lands, the Minerva robot landed, and using the data obtained, sampling final tests have been done, and we're just about to do the sampling. The final preparation was one in which the leader was involved. So could we have you explain? Mr. Tachibana, yes. Could you show the video, please? The sampler team, ever since the launch of Hayabusa 2, has had the same projectile as the one that is on the Explorer, and we've done experiments. The Ryugu surface situation, thanks to Minerva, is such that we know the details. So we've reproduced the same surface, and we've done tests as to what happens. And if you could look at this video. The projectile has been fired, and that has been confirmed. Once that is confirmed, the surface particle behavior was seen. As you can see, a large crater is created, 10 centimeters, and lots of particles are expected to come out. Several centimeter rocks will be fragmented. The smaller ones are easier to extract, and we've observed Ryugu, and we've seen the surface through Minerva, and that's why we could do this experiment. The typical sample size was questioned on the web. Could you have an answer to this? Under 1 centimeter, that's the maximum size. With this size, there's a lot of information, and we can extract a lot more information. 1 centimeter is a sufficient size. Is that what you're saying? Yes. From France, we have a planet scientist, Patrick Michel. So I'd like to ask the following.
What made you crazy about Hayabusa 2?
Oh, well, first, it's very exciting to be here. I'm crazy about Hayabusa 2 because it's a very ambitious mission, like Japanese like to do. And it has many firsts. So it made the first detailed image of a potentially carbon-rich asteroid. It made the first deployment of mini rovers and a French-German lander on the surface of such a small body. And it's going to be the first sampling on an asteroid. So this is the first reason why I like it.
Hi, Patrick.
Patrick Michel has been a great supporter of Hayabusa 2, and I asked him why he likes Hayabusa 2, and he said that it's a very ambitious mission and it's the world's first. It's first in many respects. Resource type of asteroid is very attractive, and a detailed exploration can be made, and observation can be made, and small robots can be deployed, and as we're doing now, sampling can be done. And so lots of firsts, and it's a very ambitious mission, and he's a fan of the project because of this.
Is that all these operations are extremely complex, and yet they were extremely successful so far. And I could observe the dedication and the courage and the effort of this team, which was able to even revise the strategy for landing because we had to adapt to a new situation. We did not expect so many rocks. And to see how they were able to completely change the strategy and lead to this moment we're living now, it's fantastic.
And furthermore, he said that once the mission was started, when you get there, the situation that you saw on Asteroid was totally different than expected. But timely strategy change was done, and we are now at this We have now arrived at this time, and it is quite exciting.
This is not the end of our collaboration story. We have MMX as the next step. So maybe you can tell us about MMX.
Yeah, so
and European contribution to the MMX.
Absolutely. So that's actually the third reason why I like Hayabusa 2, and of course MMX, is that it shows that science has no frontier, because we work, we are scientists from around the world. You invite us on your mission. It's very great. And it shows that, despite all the geopolitical tensions in the world, when we work for knowledge, we erase all frontiers. So that's the first message I want to say.
Hi, Hayabusa 2 then.
So in Hayabusa 2, the Japan-European collaboration is quite exciting. There are a lot of things happening in international politics, but the scientists and engineers can collaborate, and he is happy that he is part of that
to the Martian
collaboration.
moon Phobos, and it shows something which I really appreciate in Japan, is that you have a vision. You have a roadmap, you know what you want to do. You started with a sample return from Itokawa, which was an object formed at closer distance from the sun. Then you go to Ryugu, which is a little more primitive. And now you're going to go to different boundaries. So understanding the Mars environment, and maybe later go even at further distance. And I think this is really a great thing, because it shows that you have a plan which is well thought from the start, going from smaller distance from the sun to larger distances from the sun with sample returns and in situ observations. And I think this is very fundamental in science, to have a long-term strategy. And I'm happy to see that Japan is able to do so and to involve us in these adventures.
And also, as regards to small body asteroid exploration, it is easy to collaborate with Japan, Itokawa, Hayabusa 2, and MMX, because you're starting from the asteroid closer to the sun, and then go to the more distant one in order to solve the issues. And Japan has a long-term vision, which is quite impressive, and European scientists have been invited, and that is something that he appreciates.
Brian May is one of your best friends. And I think we have a video clip from Brian. Is that correct? So,
yeah, he kindly made this video for us before going to the Oscars.
Hi, Brian May.
So from Brian May, we had a message sent to us, so please take a look.
Konnichiwa. This is Brian May, and I'm very honored to be speaking to you beautiful people of Hayabusa 2 on this very auspicious occasion. I have a long history with Japan, as many of you will know, and Queen, my group, has had a long love affair with the Japanese people. From the days when we first came and Queen was a hit with the young people in Japan, right up to the present day, when our Bohemian Rhapsody film has absolutely triggered a cultural phenomenon, and we are so happy and so honored that we have this contact. But I have also been following Japanese astronomy and Japanese astro endeavors I was looking at Hayabusa 1, the mission to Itokawa, from a distance, and happy to find some images which I could make into stereos. Now I'm hugely happy to be, in a sense, part of the Hayabusa family, because I've been able to process some images from Ryugu. And this has been a thrill, and it's a labor of love for me to be able to contribute something. So I'm here to wish you absolutely the best of luck in this incredibly delicate maneuver to touch down on Ryugu. I can't wait to see it happen. I know it will be a wonderful success. My heart is with you, and give us more 3D and give us more astro adventure. We love you, Hayabusa 2.
So, Dr. Watanabe, what did you think?
Right.
It was a wonderful message. Thank you very much. However, I am an astrophysicist, so I hope he is an astrophysicist. Rather than being a member of Queen, he should come join us. And music and science are close to each other, opening up new fields and come up with something that will give excitement to people. And that is how I felt when I listened to his message. So if there is time, you were supposed to sing karaoke, but not enough time. So as the scientist, Project Science Watanabe said, in this touchdown image, I hope that he will come up with stereo images. What sort of holes were drilled, and what sort of status was done. If he can come up with that, that would be appreciated. And also, if he can compose a song, really good touchdown, that would be.
Well, Brian is really amazing because, of course, we all know he's a talent as a musician. But he also has a very high talent in stereo images. So you send him 2 images separated by some angles, and he transforms them in a 3D image in a very fabulous way. And we joke often because each time I tell him I fall from my chair when I see these images. And he does it like an artist, of course, and he's extremely generous. You can feel that what he wants is to help as much as he can. It's not, for him to be on the front. He's really an extremely generous and accessible guy. It's really absolutely fun to work with him.
So Brian May is, of course, a famous musician. Everybody knows him, but he's an astro scientist. May I go on? So as an astrophysicist, he is also talented, and he's good at stereo images. You can come up with 3D images looked from a different view, perspective. Soya-san, can you hear us? So in the control room, there was a big applause. So the sequence is progressing at the fastest speed, and we have confirmed the program for touchdown. And whether this was actual touchdown is being now checked. So we did it. Right. We made it.
Okay, so I'm trying to figure out where we are in the timeline. The timeline is very different.
Queen makes the show on
published.
Earth.
Yeah.
Hayabusa 2 made the show 300 million kilometers away. The show must go on. It's great.
Yes.
Congratulations. Congratulations.
So touchdown was
So now I can
scheduled
ask
for
you the
6:25 Eastern,
yo-yo.
which is still half an hour
So
away.
the samples are being captured, and what are we going to do with those samples? I'm sure everybody is
Okay,
interested. So
we're ahead of time.
Mr. Tachibana, can you tell us your
Go
thoughts?
mission go.
So Ryugu, as Ryugu, the name Ryugu indicates, it is related to the ocean, in our view. So we are living on the face of the Earth with the ocean, but we don't know where the ocean has come from. That is a big issue for science. And one possibility is the asteroids such as Ryugu. So once the samples have returned, then we will look at the minerals that have water or organic matters. So where the component building blocks for the ocean will come from. That is what we are going to look at as a new step for the science. And it is not affected by heat, so you can actually date back to the history of solar system. And you can, by dating back to the origin of the solar system, you can also analyze the samples together with the people from around the world.
Congratulations.
Thank you.
速報です。現在、書かれたデルタ V の量がノミナルであることが確認されま
Delta
した。
V
ノミナルというのはちょうどよ
is a nominal volume, so that means that it is exactly right, and everything is going as scheduled. It has been perfect so far.
Success never ends.
はい、パトリックさんもですね。
Patrick says that Hayabusa 2 has seen success after success. And any last words from you, Mr. Watanabe? Now that this has happened, do you have anything to say? I'm really moved. I'm very excited. My mind is not where it should be. If a sample is brought back properly, we want to share the results of this with those on Earth. Thank you very much.
Me, Patrick.
Yes, you're my best friend. Thank you.
So now, if memory serves, they are going to have radio silence for a bit of time while they are tilted away from the Earth. And hopefully we will know soon exactly what has occurred. The silence you hear, they're coming back. That doesn't mean the mission is back, it just means they're back. Okay, they're back, but they're just noise at the moment. So everyone is following up on what's going on, looking at the data, waiting to see. I'm trying to make as much sense out of that background graphic as I can, and I can't make any sense out of it. So the initial plan was that after making the initial touchdown, they would have radio silence for a period of time just due to their antenna being faced in the wrong direction by the natural geometry of what needed to be done to get down to the spacecraft, or get the spacecraft down to the surface. We're now waiting for a signal to be returned, and it will take some time to get any images that were acquired back.
Back to the studio. While we were explaining the scientific aspects, we went back to the control room because of the news. So we have a major guest here with us, and so let us reflect back on what happened. Hayabusa project manager, Mr. Junichiro Kawaguchi. Good morning. In the control room, there was a very excited atmosphere, which we've just witnessed. Could we have your impressions? The results is exactly as we planned. There was some deviation from the simulation graph, but the results are such that everything went according to plan, and that's impressive. And so it was the case the previously, but we had lots of people in the control room. People who were involved all came into the control room. Again, this time there were lots of people, and I'm very glad that everyone is happy. In the morning briefing, This is a revenge for what happened 13 years ago, or maybe 10 years, or 13 years. Yes, indeed, 13 years. Revenge. The touchdown. Rather than the touchdown, it's more about the sampling. The sampling could not be done according to the designated method. With regard to Hayabusa, there were two things that we could not do. Landing Minerva was one thing. Minerva 2 landed previously. Mascot landed. So that was repêchage or revenge. So that was a payback. And the sample, initially, in the previous time, we thought that we could collect the sample, but we thought we had collected, but maybe it was an act of God. The communication was interrupted, and we read that the sample was not collected. So the two things which we could not with the Hayabusa. Of course, this time we don't know if the sample has been collected. We have to wait and see. But probably the projectile will be discussed later on. And if the sample has been collected, what the Hayabusa could not achieve, thanks to all, what we had tried to do, what we had wanted to do for the 13 years had finally been achieved. The present situation, if we were to sum it up, data from the Explorer has not been arrived at. Yes, the telemetry has to be revived. Everything is going smoothly, but it's important to see the state of the Explorer. We want to focus on this. We will know at 9 o'clock, maybe at over 20 minutes when telemetry is revived. The status of the Explorer is what we want to know. And we're waiting to see with excitement as to the status of the Explorer. During this program, we'll be able to witness that moment. The Explorer has worked according to plan, and we've confirmed that so far. After this, accurate data from the Explorer should be sent back, and we need to confirm that to make the decision as to whether it is okay or not. The gate check was performed earlier. The checkpoint, that's fifth checkpoint, has to be cleared. And if everything is successful, then we can conclude that the movement is according to what we planned. The final decision.
Okay, cutting back in to try and say what I tried to say a moment ago. Sorry for hitting mute on the wrong feed. The reason that everyone is concerned right now is that the original Hayabusa mission ran into problems at this stage. As Emily Lakdawala is pointing out on Twitter, she writes, okay, that's cool, but it's not over. At this point on the Hayabusa mission, the spacecraft for some reason got stuck near the asteroid's surface, and the resultant overheating severely damaged its engines. I won't feel calm for Hayabusa 2 until they've successfully ascended. So at this point, everyone is nervously and eagerly waiting to find out, does the mission successfully make it back to a higher orbit, a safer orbit around this nearby asteroid? They're also waiting to find out just how much material was gathered. There were problems earlier also with the previous mission not gathering the amount of material they hoped for. So here are two things to desperately wait for. We're waiting, what's the weight of the material gathered? And we're waiting, does the spacecraft get back up to where it needs to be? So now to go back to their feed.
Astrology fans, the children and young people, it's important to feel the excitement of people on the ground. Science and technology advances on the ground, and we hope that this is brought home to everyone. If people experience this, I think it's good. From the control room, Mr. Hosoda is back, so could we have a word from you? Hosoda speaking. Just according to schedule, the touchdown has progressed very smoothly, and earlier the touchdown has been made and the separation has been completed. All of the people, including the system people, were working in solidarity. And so those people who were involved were very tense. But then we saw nice smiles, and they were hugging each other, and I was really moved.
So we're about 20 minutes away from getting telemetry back. So stay tuned. We're going to stay with this while we wait for the telemetry. In 5 more minutes, the spacecraft will rotate itself to face towards the Earth, and then we're just waiting for the data to make it from the mission to us here on Earth.
Kawaguchi, when you came here, you had a big smile, and thank you for bringing this atmosphere to the studio. Yes, I'm very grateful. 14 years ago, data analysis, which followed, well, we don't have to do the analysis. It was very tragic. After ascent, the posture attitude was very unstable. The reason for this was when we analyzed, we found that the fuel gas leakage, there was fuel gas leakage. And we had deferred the press conference, and what we were doing in the meantime, we're trying to stop the leakage. And we finally stopped the leakage. And we were at the press conference, but there were no smiles. We were at a loss as to what to do. So we're very happy, and that's good. And we hope that we stay happy. The Hayabusa project, from launch to return, or before launch preparation, and after return, there has to be analysis. One project requires over 10 years.
Yes, that is right. And successor to Hayabusa is now touching down, and this is also a 10-year long project. How you can develop young researchers, and that is very important. Yes. Well, 5 years in duration would be the most welcome to us, because graduate school students will stay in the university for 5 years, and then they can be exposed to the front line of the space exploration. If that is the experience that they can have, then that would be very helpful. But if that is disrupted and there is intermission, then that is not good. So we hope that this will be continued. So with Hayabusa 2 success, there must be more people who are coming into this field. Yes, I hope young people will come in and work with the young active members now. So according to the rule, I will be retiring by March this year, but we're not told not to receive the pension benefits so early, so I will stay for another 2 years. So perhaps you can stay here until the explorer will return. So yes, I will stay here until 2021 to make sure that there will be a successful return. So it is just a one-way trip that is over. So I hope you can focus on impactor. What does this impactor mean? It is to create the artificial craters by having these bullets. And Hayabusa 2 has a higher degree of completion, but what should excite people is that this is the first in the world. This has been incorporated into Hayabusa 2, and this was the first time in the world. And this is exactly what you mean by opening up the new field, and this must be quite exciting because you are engaged in something that has never been done before. So this is the beauty of being a part of part of this team. Well, and that is going to be done around April, according to current plan. So you cannot keep your eyes off. Now, let us take a look at the messages from via Twitter. So let me share some of them with you. Jill Zusa said that this is the project that has been going on from the first Hayabusa 1, and I'm pleased that Dr. Kawaguchi will stay with us for another 2 years. So that was the message coming in. And the Hayabusa 2 touchdown success, very pleased. So it will return at the end of next year. So I hope it will keep up the good work. Well, Dr. Kawaguchi seems to be extremely happy. And so this is another fan of Dr. Kawaguchi. I thought it would be 8:25, and I was preoccupied by the house work, and I missed the touchdown point.
I'm not the only one with the wrong time.
Video. So the message to the children who are would-be researchers, and that was the request from Tanaka-san. So when you say space development, you may associate that with the numerical data or signal data. But what's different about Hayabusa 1 and Hayabusa 2 is that you're bringing some materials back. So it's not just about numbers. And this is a huge experiment, or field work, I should say. And so it also comes along with the experiment, and that is the most important point. Hosoda-san, can you hear me? Can you hear us? Do you have anything to say? Telemetry is supposed to come back, so everybody is now getting prepared. So in front of the control room, everybody is standing, nobody is sitting.
Telemetry will let them know if the mission has returned to a standard orbit or if it had the same problem as Hayabusa, the original.
Integrity, and also whether it has fired the projectiles or the bullets, what we call bullets. It takes more time. So Doppler is a display that will show the radio frequency, and that is the only thing that they can watch. And telemetry has come back, and you can confirm that on the screen. Yes, we are seeing telemetry. In front of us, there is one screen that can show the telemetry data. So a big applause again. So everybody is filled with smiles. The project manager, Tsuda, is all smiles.
You can see it's back up to 800 meters again, so they are at a safe height above the planet.
Telemetry has returned.
Asteroid.
Elaborate more on that? So from Hayabusa, there is data coming in. You have to have a big antenna facing the Earth for the data to return, and in order for the spacecraft to touch down on the asteroid, the antenna has been shifted slightly, and now that touchdown is over, the antenna or the Explorer is now facing the Earth and now starts to send the data, and that data is now coming down, and more detailed data about the spacecraft is now coming in. The person who's responsible will start checking. Another applause. From the control room, yes, over to you. The projectile firing was confirmed. So in Hayabusa 1, it was not fired. The projectile was fired. So Dr. Kawaguchi, how do you feel? Well, I just want to jump. So this is the most crucial point, whether you can confirm that the projectile has been fired. The project manager, Tsuda from JAXA, and project manager Oshima from NEC are now clapping their hands. And in front of them, the person whose hand is on the chair is the young researcher. And from the manufacturer perspective, he has been controlling the procedure of the operation, and now all his efforts have been now rewarded. So Hayabusa 2 will ascend to the home position? Yes. So Mr. Hosoda is now back at the studio. Welcome back. So how did you feel when you were in control room? Well, the excitement of the site was felt, and the people with each of the responsibilities has to be checked and confirmed that their areas of responsibility has been successful, and that has been confirmed one by one. And then the integrity of the spacecraft is now being checked, which is checkpoint 5. So there's only one left for checkpoints. Right. And looking at the answer, the final decision or judgment will be made.
So the translator that you're hearing...
So you were not here when there was a...
The translator that you're hearing is translating in real time what's going on and has a group of very happy scientists in front of her who are blathering a bit. So she is translating both the hosts as well as this wonderful fellow who is the mission scientist. These are really great human beings. We had the chance to meet them last summer at the International Astronomical Union meeting, and they were just very generous with their time and sharing their passion for this asteroid. So they're now talking about how reassuring everything is for the scientists in the control room. You can see they've now gone from the eager anticipation milling to the just general milling. The audio coming from the feed is now switching over. I'm trying to figure out where they're going to. It's currently just noise in the control room. You can see the people on the left pointing up at the camera. One of the reasons that you're going to see super happy, super young people is in some cases you propose a dissertation that requires the spacecraft to function. Don't do that if you like yourself. And if your spacecraft doesn't work, your dissertation goes away and you get to start over with a new research project, or you end up with a project that just isn't as good. So lots of students just had their careers made.
It's about how you were involved in this project, and introduce yourself. As has been introduced, Hayabusa 2 posture attitude control is my area of responsibility, and that is how I was involved in the project. From the development phase, I was involved, and after the finish of the development phase, as is the case today, I'm involved in the operation. The attitude control is the linchpin, it was mentioned earlier, and things have progressed very smoothly. Yes, when we moved into the mission phase, a lot of the aspects has proceeded according to plan. And as you mentioned, attitude control system is a subsystem which impacts various other aspects. It's really a linchpin subsystem. And as one member of the team, that this is going smoothly makes me feel proud. Specifically, with regard to Hayabusa 2 attitude control, what aspects were difficult, and what aspects did you struggle with? In the development phase, I was involved since the development phase, and toward the launch, there were lots of difficult periods, and even after operation, when it was cruising, things were smooth. But at the mission phase, after landing on the asteroid, there were lots of critical things that happened, and so operational design is something that proceeded before arrival. And the screen is divided into 4 compartments. The young 2 members are the attitude control related. On the left-hand side is Mr. Ono, and on the right-hand side is Mr. Yoshikawa. And next to me is Mr. Mimasu, in their latter 20s to in their early 30s, who are very active on the ground. And it's only Mr. Mimasu that was involved from the development stage. Mimasu and I were involved in Hayabusa 1. We were, as students, involved in the operational aspect when Hayabusa 1 returned to Earth, and he is a senior to me, so I learned a great deal from him. During the development phase, as a senior member, he has given me much guidance. So in this way, knowledge is succeeded. Do you have more men? In the control room, there seem to be a lot of men, and from what I heard, the return control, when we looked at that room, it was just men. Yes, there are some women. There's one woman, but in the engineering faculty of universities, it tends to be more men. And for the same reason, basically, the present status is such that we have more men. What made you involve yourself in the attitude control? Yes, I like space very much, and satellites and spacecraft movement in space is my area of interest. And I thought that in an area where I could play to this motivation was attitude control, was one of the options for me. So it's 300 million kilometers away, and the diameter is several meters, a mere several meters for the spacecraft. And to control a spacecraft is hard to imagine. It's difficult to imagine. It's very far away. And so people have the image that it's hard work and it's difficult because it's far away and remote. The most difficult aspect is that because of this distance, there's a lag in terms of communication with the explorer. And so people were struggling to find out.
I'm just going to interrupt for a moment to point out it's already 6 kilometers back up. So that sucker's rising pretty quickly.
In this context, we have to control this spacecraft. So we have to predict 40 minutes hence to control. So in the area of control, that's the most difficult aspect, the time lag. And this time, in addition, the moment of touchdown or toward the touchdown, communication was interrupted. Yes, the last phase is such that because it's low reception antenna, and the sequence occurred when we switched to the low functioning antenna, and information was very limited. In the end, Doppler information, Explorer speed information was used, and that was the only thing we could monitor to confirm whether things were.
Interrupting again. You can see they're slowly starting to all stand and face in the same direction again. This is because we are getting to the point that we should be getting the next set of signals back soon. It's starting to settle into a set distance, so you can see it's actually oscillating in height. So keep an eye on the height that they're at right now.
In communication frequency, what is moving brings about a delay in frequency, and from this delay, the movement of the explorer can be imagined. So the movement has been exactly as verified by the simulator. Can you also predict in which way it is moving? It's restricted to the direction of the Earth, so it's one directional. It's one particular direction only. We're limited to that. the vertical direction movements cannot be ascertained. The explorer just doesn't move just toward in the direction of the Earth. So it's only one aspect of the movement of the spacecraft that we can confirm. The attitude control has gone very.
So we're currently in the rising phase of this spacecraft. You can see that we have very quickly gone from above the planet to capturing the target module to lowering down to touching down within a 6-meter box to taking off and now rising to being roughly 6 kilometers above the surface of the world.
Were involved in attitude control. With regard to attitude control,
the question's how many
the
on
overall
the
head count is about 20, more than 20 or so. In one shift, 6 people would be working.
Green number is the altitude, yes, Bad Panda.
Shifts, so it's 20 people or so. So we've had some questions through Twitter related to attitude control. Imamura-san, could you talk about it, please? From the Shironagasu Kujira, do you use thrusters for attitude control? The science thruster and reaction wheel, do you use both? Could you explain both? The question was about the use of the reaction wheel or the thruster. It's only a lot of professionals are listening. The reaction wheel is a disk that has a certain output, and this rotates. It's a counter reaction which moves this, and it's the counter reaction. The explorer works in the opposite direction. It's the actuator. Yes, so you have to make sure it doesn't move in the opposite direction. Well, it's the reaction wheel moves in a certain direction. The explorer moves in the other direction, and we use that to control. The reaction wheel is used for very precise control, and the science thruster, what's that? It's the science propelling system. A rocket engine. It's a small-sized rocket engine, you can say. A rocket engine has enormous force, but it's reduced to about 20 newtons or so. What's 20 newtons? So is that difficult too? 1 kilogram is 10 newtons. So 2 kilogram, the push is about 2 kilograms strong. It's pushing with a force of 2 kilograms. Can a human being push it at that magnitude? Yes, it's the size of the kind that human beings will be able to push. It's like a rocket. You use the principle of a rocket, and it's a propellant system, a more forceful system. And the other is used for more detailed control. When you use broad brush propellant, you use the science thruster. But you use fuel, so you want to save fuel. And you want to control attitude, saving fuel. Is that an important thing to do? Yes, indeed. When it's normal, then reaction wheel is used to stabilize the attitude to descend and to operate. The last phase was such that the explorer wanted to land on the asteroid, and immediately the attitude has to be changed, and you need the scientific thruster to do the forceful control.
So to get back to what we were discussing, since we are looking at the control room, how many female researchers are there? It's very difficult to count. Right in the middle of the screen on the right, 1/3 from the right. Can you show that? On the screen, there is a commander who is entering the commands, and that is a female engineer. So in the touchdown operation, the person who's sending the command is a female, and she is not a scientist or engineer in the background, but she's a young person, and she has obtained the qualification for radio communication in order to get involved. I'm not sure if to what extent I can go into her private information, but she talks about her pet rabbit during the operation, and this really gives us a relief. And as a Hayabusa 2 system operator, there is one woman called Hirose, and also sample analysis is being done by a female called Sakamoto, who is going to come to the studio as a guest later. And HDA and LGA are used for touchdown operation, high gain and low gain antenna. But why is it that you don't use middle?
So this is the point where we are watching them all kill time to get more data back from the surface of the planet, or rather they're waiting to get data back from the surface of the asteroid. And so while they kill time, they're answering questions from the internet. If you find this painful, this is because the questions come from the internet. I am here to answer all of your questions as we wait. We will probably be discontinuing this coverage once we have confirmed that Hayabusa is, well, all alive and well. And I'm going to go find some dinner so that I can make sure I am here and ready to sit in the chat when our own Annie Wilson, Binary Ablaze, streams tonight's SpaceX launch, which is going to be carrying Space IL's Bereshit lander all the way to the moon, making Israel the 4th nation to safely land. We hope, we plan, on our nearby world. Now, this particular mission highlights the fact that Japan just bypassed the moon completely, going on to explore asteroids not once, but twice. This particular touch and go is the first of 3 planned touch and goes. We don't currently know the next date that this will be occurring, but we will, when it happens, be bringing it to you live. Now, the reason that they're doing 3 different touchdowns on the surface is because they want to collect different types of soil samples from across the surface of this nearby asteroid. As they go, they are, struggling to find one of those 3 types. So they do know that they will be doing the 3rd planned landing, where they're going to be actually dropping basically a small explosive, exploding a small area of the surface, revealing deeper materials, and then swooping in to catch that material later. So at this point, we are watching the numbers. They are 6.5 kilometers above the surface at this point. Their altitude is varying as their, elliptical orbit carries them around different points, and as they go over, different shaped parts of this oddly shaped particular object. Now, they're currently answering questions about antennas, but we can see the anxiety, the anxiousness rising as the humans stand and all begin to point in the same direction in the control room. The closer we get to getting the data back, the more humans are staring at the screens. So they're continuing to just discuss antennas. So Paranor is asking 2 years for the return. I think it depends exactly on how they plan to do the mission. These are the kinds of things we don't worry too much about, at least not until we get everything. So let me see what I can find on the mission timeline. I thought it was a 2020 landing, but I still want to double check. It does have an ion drive. Yes, so the samples will be returning in December 2020. So it will leave Ryugu in December of 2019. It will spend 1 year on its journey back, and then we'll have those samples. So this is a cool little mission. So the thing is, while TIE fighters are twin ion engine fighters, the ion engines imagined in the Star Wars universe are ones that are capable of moving things much faster than any actual ion drive we've been able to build is able to do. The force exerted by ion drives, like those on this particular spacecraft, exert about as much force as, well, a piece of paper exerts on your hand when you hold it up above your desk. This isn't a whole lot of force, and if that's the amount of force you use to try and move something the size of a tiny car, it's going to take you a while to accelerate to a useful velocity. So even though this spacecraft isn't going all that far, it's going to take it a while. For comparison, it only takes us about 0.7 of a year to make it between Earth and Mars in a similar kind of orbit. So we're continuing to wait. They're talking now about the ion engine on board the spacecraft and showing the size of this little tiny spacecraft next to a human being. So let's see the next question. How can you distinguish the uses
to put
of the different
the
systems?
spacecraft on the orbit to reach the Ryugu? That is important. Well, in Hayabusa 1, I was not involved in operation at all, but we struggled with the launch of ion engine, and there was very little time for them to prepare for landing on Asteroid. But actually, Hayabusa 2, everything was going well, and as long as ion engine is functioning well, then this white, if you can go back to the studio, this whiteboard that shows 50 times of rehearsals or practices, the members of the team were able to spend this much time for training, and that was what the project manager told us, and I really remember that well. And there's a quick question. So MGA will not affect the attitude control, but what about the counter action? Would you rotate the oil wheel to operate? Well, to be more exact, the middle gain antenna, the counter action of the action of middle gain antenna could affect the attitude control slightly, but for attitude control we use the reaction wheel to make sure that it will be kept in the same direction, and that is the autonomous control. So even with the torque from counteraction from middle gain antenna, there is a control force from attitude control system to counter that. So there is very little impact on the attitude control system. So this is not a question addressed to Mimasu-san, but there's a question from a child. So let me read this out. When the capsule is delivered to the Earth, is it going to be delivered to a different asteroid, and then the samples that have been collected, what would happen to those samples? So is there any plan for the samples? And that should be answered at the press conference. As a project member, one project member, if that sort of dream is there, then that would be exciting. I personally think that we want to go to a different asteroid. Well, it's not a sample return mission, but in the US there's an explorer sent out with the ion engine, and after looking at the asteroid is going to the Mercury. But we just succeeded in first touchdown, so we're not there yet to consider that much further down the road. Well, children are saying that this is a dream. Well, not that far away, but in April, May, June, there will be more crucial GCI operations and others will come out, as Dr. Kawaguchi said. So unless we pass through all these operations, we cannot talk about this dream type operation.
Mima-san is wanting to go back to the control room. So could you bring Mr. Sakamoto in your place, please? Yes, I'll do that. Thank you.
So I'm not quite sure what they're geared for. I know there are a whole lot fewer people standing now than there were a few moments ago. Reporting by judging what's going on based on people standing is a thing you do with aerospace.
Earlier in the broadcast, projectile firing, it was said, was confirmed. There was something mentioned to that effect. More accurately, the projectile firing command issuance has been confirmed. You might think it amounts to about the same thing, but the command issuance has been confirmed. That is a more accurate expression. So,
to put that a different way, they know that the machine commanded the gun to fire. They don't know if the gun successfully fired.
At the press conference, I think details will be addressed starting 11 o'clock, I believe. Hosoda-san is back. The control room is has calmed down a bit. Yes, the telemetry has come back, and people are very carefully looking and confirming, and so we want to keep an eye on this.
So if I understand what's going on, they have now received the data back, and there are people who are currently working on processing the data they've received back. They are crunching as fast as they can. They're planning to do a press conference at an o'clock. I don't know. So they're trying to figure out so the question's being asked, what's the green thing?
Uma doll. When they went to the shrine at the beginning of the year, they brought this back, and when the wish is granted, the two eyeballs are painted in, and so that is what we want to do. Behind there are photographs of asteroid Ryugu, and what are those photographs of Ryugu? Landing on Ryugu, and Ryugu rotating is being shown here. If you cross your eyes, it looks like it's just one Ryugu. Was it used to determine the landing spot? Brian May took this image, and he created a green and a red colored image. If you would use a special glass, it looks like a 3D object. He's very talented, isn't he? Yes, he's a scientist, astronomist. We have two people here now.
It's very
Mr.
hard to follow.
Sakamoto and Mr. Tachibana.
The translator's
Mr.
translating
Tachibana talked to us earlier. Sakamoto-san is responsible for curation. So what does the curation person do? Could you introduce yourself? Kanako Sakamoto is my name. The samplers, the containers containing the samples, and the container, when it's brought back, we would open it. and we have to carefully manage it so that Earth substances do not enter the container after unsealing. And we distribute it to the researchers, and we're making preparations for this. And I'm responsible for that. The post-sample return work is what you're responsible for. Yes, in terms of curation, we're waiting for the sample return. The researchers all over the world want to get their hands on the sample. Yes, I hope and pray that we could actually bring back the sample. Could you introduce yourself once again, Mr. Tachibana? Sampler and sample analysis and putting together all the results is my responsibility. The analysis, specifically, how does it proceed? I'm sure researchers worldwide want the sample. What are the rules? And what is the sequence? Could you briefly explain? First, as Ms. Sakamoto explained, the curation in the facility which will be created, we confirm once again whether what has been returned is from Ryugu and what is the volume and what is the size. Before coming into contact with air, we make decisions on these points. And after this is done, a part of the sample we send to analysis within Hayabusa 2 team. And as mentioned earlier, as the name indicates, the origin of the ocean and the origin of the solar system will be studied, and scientific analysis will be performed for this purpose. And based on this, we determine what Ryugu is and how attractive the sample is. Having introduced that to the world, we want to share the sample and analyze. The curation facility will be created on these premises. This is to be built from now. With regard to Hayabusa 2, it's completed. And this is called the chamber. And it's important, Mr. Tachibana said, that we determine it's actually a sample from the Ryugu. We have to make sure that things do not mix from the Earth, and so we seal it. And before it comes into this the atmosphere, we introduce it into this facility and take out the contents of the container. And this has just been completed this year, and it's a picture taken from above. What's bad about samples coming into contact with the atmosphere or the air? Water and organic matter is a key word in scientific analysis. When you say water, we have vapor in the air, and when you say organic matter, human beings are organic matters, and so we don't want to contaminate the sample. So we will handle the sample in this facility so that it does not come into contact with the air. So is it a vacuum? There's a part of it which is a vacuum, and then a nitrogen, pure nitrogen. The first half is just vacuum, and the back half is nitrogen. And specifically, what kind of analysis will you perform? The analysis we perform in the project is one which we will be doing with the researchers of the world. We have created 6 teams. Ryugu sample, scientific, chemical features, isotopes, and elements will be checked. And then what will be collected are rocks. And rocks have different minerals. It's a mixture. And so the rocks and compounds will be checked by 2 teams, one dealing with the larger particle, the others with the smaller particles. And the volatile matter, there are items prone to become gases. We hope it'll be there. And this is related to the ocean and life. And there are people who will be analyzing that. And there's another team looking into organic matter. And there are 6 teams altogether which will be engaged in the analysis. All will be performed in this chamber. within the chamber, we will check the nature of the substance, and photographs will be taken and catalogs will be made. The actual analysis will be using state-of-the-art devices. So without coming into contact, the samples will be placed in boxes, and it will be analyzed in Japan and in other parts of the world. So without coming into contact, the samples will be contained in a box, and it will be distributed. And that's the process we call curation. And in Japanese, it would be...
I just want to give kudos to this translator. She's translating at 10 million miles per hour with multiple voices that seem to be talking over one another. So currently they're talking about what the words are for the people who collect and maintain the rock samples. This is just very impressive. We're now watching the scientists laughing back and forth. You see someone's stuffed sea turtle in the background. And everyone, the senior people standing around in many cases, waiting for the day-to-day scientists to get all of the stuff ready for the press conference. This is the stage where you have to actually analyze the data that's coming in. So here we go.
And Itokawa was mentioned. In the case of Itokawa, the sample volume was smaller than expected. How much was the volume? I don't remember.
When you opened it up, there was nothing that was seen. That was how little the volume was. And then some particles that are even smaller than the tip of the hair strand. And there were about 700 of them that were picked up. And they were distributed to the different countries in the world, and the research is still ongoing. And with Hayabusa 2, the samples are coming back and brought back. So how much do you expect to see? Well, the nominal 100 milligrams, so a spoonful of samples. In the case of Hayabusa 1, you are not able to see anything at a glance, but you're expecting to see a spoonful. Well, touchdown was successful today. We're not sure if the projectile was actually fired, but if it was, then something that is visible at least will be brought back. We expect that to happen. And then ejector.
So that's
it's not the projectile that we're talking about this time. That SCI, the impactor. Are you talking about the impactor? Yes. The impactor, more samples are expected to be collected, right? Well, the sample collection is done by the sampler horn that is on the screen. And the impactor is there to create crater in the asteroid to extract the substance inside under the ground of the asteroid. And with the solar wind, the substance may have been changed on the surface. And how many centimeters? If you dig how many centimeters, some centimeters deep, then you would be able to pick up the rocks that had not been affected by the solar wind. And so that's what the impactor was doing, designed to do. So the impactor is not there to actually scoop a large amount of samples. So it's almost like being sunburned on the humans. There is a lot of particles flying in with the solar wind, and that's what we call a space weathering. And particles that are not affected by that should be collected with the from the crater where the SCI has worked. So after the sample return, if you become busy, then that will be the best. Yes.
Everyone is
So all the
clearly-
members are now called to join the joint photo. So thank you very much.
So they are now gathering everyone to take a picture. I am hoping that following the picture is when we're going to go over to the press conference. I have to admit, struggled to figure out which top of the hour they are planning to have their press conference at. Let's see, Annie and I are working on figuring things out. Okay. So we will be switching from coverage of Hayabusa straight over to coverage of the SpaceX launch.
So you're looking at the control room now on the screen, and all the project members are gathered to take a commemorative photo. And
Apparently they're not including their translators in the team photo. So as I was saying, we are going to be switching from live coverage of the Hayabusa 2 encounter with the Ryugu asteroid and hopefully a correct sample return. We'll be going from this coverage over to our live coverage of tonight's SpaceX launch, which includes the SpaceIL lander to go to the moon. This is one very international day for space science, where we have a ESA JAXA-led mission encountering an asteroid, and we are going to have a SpaceX, which is run by a South African who's emigrated to the United States, rocket that is then going to be carrying an Israeli mission. Space is truly shared by all of us. So stay tuned. Don't go anywhere. Let's watch this ridiculousness that is the entire team getting in there to get their pictures taken. And hopefully we will be going straight over to their press conference, which I, for one, am really hoping will include some images returned. We do know that people have been madly crunching on things at their computers. We are now madly trying to get everyone to fit within the frame. I love how some things are the same no matter where you are in the world. Trying to get everyone in a photo is always a struggle. So as a standard station identification, you are watching CosmoQuest X on Twitch or perhaps over on YouTube if you are watching this as a video on demand after the fact. I am Dr. Pamela Gay. I am one of the hosts here on this channel. We are part of CosmoQuest, your place to learn and do science. And we are a production of the Planetary Science Institute, working in collaboration with Youngstown State University. If you enjoy what you see, well, give us a follow and find out every time we go live. In addition to bringing you launches, landings, and all these other spacey encounters in real time, we also bring you the Daily Space, a Monday through Friday show that brings you the latest news from space and astronomy. Tune in at 1 p.m. Eastern, that's 6 p.m. London, 10 a.m. Pacific, Monday through Friday, to find out, well, all that's new in this universe we share. We are sustained by you. This program is funded through the generous contributions of viewers around the world. We are so grateful for all your subscriptions, every bit you've dropped in, and all of this goes forward to keeping the science going. If you think this is interesting, stay with us. In the coming months, we're going to be offering you opportunities to work with the OSIRIS-REx mission as they find the place that they're going to pick up their own rock to bring back to Earth. We are not just a Twitch channel. We are an entire science facility that offers you a front row ticket to be involved in all sorts of different global activities. Now we see them slowly ducking out the various corners of the room. Sorry, I have this up on 2 different streams and I'm not entirely sure where to look at any given moment. We're now all waiting to see what is going to happen. Now, for those of you who aren't familiar with Japanese custom, when you see people wearing what look like medical screens, that's not because they're afraid of getting sick. It's because they either have allergies or are afraid of getting others sick. It is a sign of courtesy to the people around them. We now see people gathered around talking, looking over things hot off the press. They are passing around something that they're signing. I have no idea what it is. I love the guy in the front left who is diligently checking his printouts against the screen. Every mission has that person, that triple check that goes on. It looks like they're passing around maybe a site landing map that they're getting people to sign. I can't really tell. These are the things I want to know. There's a NASA representative in the back you see with the NASA polo, which is pretty much a requirement for these events. There is a lot of overlap, in particular between people working on Hayabusa and OSIRIS-REx as they work to support each other in asteroid exploration on these 2 very similar missions that are doing similar science, but with 2 totally different asteroids, allowing us to get an even better understanding of our nearby solar system and the kinds of rocks that ended up sharing the orbit with Earth. So we are now 4 minutes from the top of the hour. I am flipping through the feed to see if I can find out if we have any more information on when the press conference might be happening. I'm seeing lots of thanks going out, lots of congratulations. Not seeing information on the press conference. Hopefully someone will come back and let us know. So what I can tell you from looking at the screen is that the little robotic probe that can is now orbiting 6,700 meters. That's 6.4 kilometers above the surface of Ryugu. We don't know if it has in its little scientific belly a sample of the asteroid's surface or not. This is what we are staying on to find out. Once we know, we will probably be switching over to Annie to bring you the SpaceX coverage. If you have any questions, I'm here, and I'm also trying to kill time. Okay, so Super Cowboy thinks they said 11 a.m. local time. Let me find out what time it is in Japan. And when you type things into your wrong search, okay, so it's only 2 minutes to 9 a.m. right now, so that would be very sad. So if we are currently 2 hours away from the press conference, we're not going to stay with you that long. But this live stream is continuing, so I'm hoping they're going to come back sooner rather than later. I have a puppy that has decided to come and investigate. While killing time, I will introduce you to my interrupting dog. Come here. I know. Okay, this is little Stella, who is no longer all that little, and she likes to invade our live streams, and when you donate money, she sometimes gets treats thrown at her. She is an Australian Shepherd puppy that was born September 23rd and is now about 4 times bigger than she was when we first got her, and is considering running away. Yep, there she goes. Okay, go. Okay, and the dog runs. So yes, Hugo. Her full name is Stella Sky. Sky spelled as the Scottish island because she's as stubborn as you need to be to survive the weather on that particular island. she is indeed a little troublemaker. So I'm watching everyone talk, wondering what's going to happen next. Oh, this is where you really see the difference between the different nations' live streams. Thank you. I like her name too. My husband actually named her. So they have something angrily beeping on their end. Not sure what else is going on. So here we go with all the anxious waiting. In this case, not to find out what's going on with the spacecraft, but to find out what's going on with the feed. Okay, still nothing. Everything is going good so far. We just don't know if they succeeded in getting a sample or not. So the materials that we expect to have in the sample are basically the same kinds of junk that you get in meteorites. There is someone with a stuffed animal and a message taking over the webcam. I don't know what stuffed animal he has. Thank you, Scott Bragdon, for subscribing for 7 months. But that crazy fish really looks like a Goa'uld from Stargate. I'm just going to lay it out there. He had a stuffed Goa'uld. Yeah. Oh, that's amazing that we're it for rocket coverage. Go team. So for the rocket coverage later today, it will be Annie as host. I will be here in the chat cheering on yet another little spacecraft. And Annie, I'm just waiting. She is almost ready. I'm typing over to her. They're announcing something, but I don't speak Japanese, nor is it loud enough that I could hear it if I did speak Japanese. I'm going to switch over so you can hear what I'm hearing. So I have information coming in from Twitter. Let me mute the noise in the background. So from the official Hayabusa 2 at JAXA English feed, at 8:42 Japanese time, the following has been confirmed at Gate 5. Projectile was commanded to fire, normal sequence. Spacecraft state is normal. Based on this, we determined touchdown was successful. A detailed analysis will now be done. A group photo was taken in the control room. Now everyone is back at work again. So this is what we know. This is what we know. That, and they're beginning to get silly. I'm sure they've been awake in many cases for quite some time. And so, yeah, now it's just that waiting to find out what is the next big piece of news to come out of this little spacecraft that can. So in other news for space science, NASA is putting out their press information on the SpaceX Demo 1 launch that is currently scheduled for March 2nd. The media advisory is out, and they're planning to begin press briefings on February 22nd. The launch is currently scheduled for 2:48 a.m. March 2nd, with an ISS arrival at 5:55 a.m. March 3rd. I'm so not going to be liking that. So yeah, we're gearing up towards the demo at a terrible hour. I'm kind of hoping that something happens that just delays it a little so that maybe we get a slightly friendlier launch window. So it is a busy time for space exploration, between new nations getting involved in landing on other worlds to this. Oh, it's still in Japanese. Hold on.
Things were developing in the control room. We're drawing near to time to close. Back to the studio. We want to extend the program a little bit. We will be broadcasting until about 20 past 9. The last guest we have with us is the director of JAXA, Dr. Kuninaka. The JAXA ISIS director, Dr. Kuninaka. Hayabusa 2 and Asteroid exploration. Beyond that, could you discuss some broad themes? Back to the image, please. This is. We'd like to first of all thank you for supporting the Hayabusa 2, and let me talk about what lies ahead. What you're looking at is the solar system. The closest to the solar system is Mercury and Venus and Moon, the Mercury and Jupiter and Saturn and so forth. A lot of explorers are within the solar system. The first explorer that we launched was what we launched for the Halley comet, Sakigake, and the two explorers. 1985 is when we successfully launched it, and since then it's been, well, including plans for the future, over 20 explorers, a spacecraft, have now been launched into the solar system, and some of them are Japanese explorers, and then there are those which we have developed jointly with the United States and Europe, belonging to us. Last year, in October, as a joint program with ESA, Bepi Colombo is the explorer we launched toward Mercury. 2018 was the launch in October, and it'll land in 2025. It will land on Mars. It's an ESA-JAXA joint program. Japan created MIO, the explorer, and Europe's MPO. Two explorers will jointly explore Mercury. And what is under development is SLIM to land on the moon, and we are in the development process. It's a 100-meter scale, high accuracy, pinpoint landing technology, which we wish to acquire through this. It's the major target. 2021 is the time we plan to launch. Close to the equator of the moon, Mickey's Ocean is where it is expected to land. Mantle substances where rocks are exposed. We want to land the spacecraft, and we wish to conduct precise analysis, an accurate analysis. And further in the future, we have MMX, Martian Moon Exploration Program, bringing back samples from moons of the Mars. There's Phobos and Deimos. These are moons, Martian moons. We want to land on either of these moons to collect samples to bring that back to the Earth. It's a large-scale project. 2024 is the scheduled launch, and 2025 is when it was expected to land at the destination, and it will observe Phobos Deimos, and it will land on either, and it will collect the sample and come back to Earth. 2029 is the scheduled time for return, and that is also a major project. 2025 it'll start its activities on the Mars atmosphere, and the Osaka Expo will start at this time, and we want to to present real-time photographs from the Mercury at Osaka Expo. And also with regard to Asteroid Phaeton flyby project. Destiny Plus is a mission which we went, and the launch is scheduled for 2020. And the Asteroid Phaeton is the mother planet of the Gemini, and by precisely observing this is believed to be the origin asteroid that brings a lot of comets to the Earth. And JUICE and JAXA, a joint product, several observation devices have been contributed by ourselves, will be provided by ourselves. And Jupiter Ganymede is where we want to spread our observation. 2022 is the scheduled timing of launch, and at the Jupiter moon Ganymede, on the surface there's ice. Underneath the ice, there's an inner ocean, the inner ocean on this planet. And we want to do an observation of this. And a sample return of the kind, the sample return from Hayabusa will be returned to Earth in 2020 in a capsule. We want to develop the sample return technology further. Hayabusa 1 and 2, the capsules that will be used will be a larger size, which will be sent on MMX. This will be used for sample return from Mars. And a larger capsule is under development at the moment. This is a joint program with NASA in the United States. And CAESAR is the name of the mission. Cerimus Brascomus will be where the Explorer will be sent, and samples will be returned, and it will be brought back on a large sample container. It's a large project. And the key words here is water. There's a lot of water, people think, on Earth. But if you could see on this chart, on Earth, compared to the volume of the Earth, there's only 0.1% of water around Jupiter and around Saturn. Europe, Callisto, Titan, and Ganymede, these are the moons. The size of the body is very small compared to the Earth, but the water contained is a vast amount. And that is what people think. And what this means is that inside the solar system, from Mercury to Saturn, there are rock planets. But beyond that, there is Jupiter and Neptune and Pluto, which are gaseous. And there's a lot of water there in the form of ice. And after the creation of the solar system, beyond the smaller line, water was brought back from Jupiter and Saturn, people think. And it would be comets and asteroids and cosmic dust. These small celestial bodies contained water, and that was brought to the Earth, according to some. And the important role was played by movement of substances within the solar system. And it's cosmic dust and asteroids and comets which played a major role. And we're trying to do more research into this missing piece through our work. And as is shown here, we distributed a lot of explorers into the solar system. We want to gather data from multiple number of explorers, and through the swarming system, 4.6 billion years of the solar system will be explored. And that is what the ISIS wants to do. And this is the exploration strategy. It involves not only only the solar system, but with regard to space, PRISM X-ray imaging spectroscopy is being developed. In 2016, there was an accident. We lost STRO-H. This is the successor unit to that. In 2021 is the slated or the development target date for launch. CRISM, this is X-ray spectrometry, and infrared telescopic speaker, a microwave telescope, Lightbird is what we're contemplating, X-rays, infrared, and radio waves. We want to integrate all of these here, to try to clarify the 3.6 billion years of history from what has started with the Big Bang. We want to bring all of these frequencies together to try to explore the history which started with the Big Bang. And as mentioned, ISIS's astronomical and solar system research is, as I have explained. We hope that you will continue to support and cooperate with us in our endeavors. In particular, to the younger people, please do take on the challenge of doing work in space and technology and JAXA and other space-related projects. We hope that you would participate so that you could join with us in trying to develop our future. And that is the message from me.
So there was a failure of Hayabusa 1, but all of those lessons were learned and corrected in Hayabusa 2. But that is reflected in all the explorations and the research and opening up the frontier of space. The technologies and science that are required to do that will be accumulated going forward. So as the head of the ISIS, he has covered all the areas and has given consideration to all the areas. But at the outset of the program, well, you may have heard this, but there was some commitment shown by the head of the ISIS, but that was prior to the launch. Well, at the time of prior to the launch, you shouldn't uncover our secrets, but actually at the Tanegashima island, right before the launch of the rocket, the words that he shared with us, similar to those were given, and I was moved back then, but I'm quite impressed that this has been web streamed on the internet, so everybody got to hear what he had to say. So I was very pleased. So Imamura-san was one of those members that were inspired. And there's one comment from the Twitter, Bartman, JAXA and ISIS, all the ISIS members. The success and achievements are not the result of the research activities, but this can give the power and dream and hope to the children. And I really pay utmost respect and congratulations to all of you. Well, that was the message, and I think this room is also filled with passion, and those viewers that are watching this program through the web streaming, we are hoping that this passionate atmosphere can be conveyed to the viewers watching this program. Mr. Hosoya has come back from the control room, so can you give us the update? So I'm back. Well, currently at the control room, the Gate 5 completion was declared, meaning that the Explorer spacecraft is on its way back to home position. And so gate 5 has been successfully passed. And there's not going to be any major development in the control room anymore. So with the completion of gate 5, the program is complete. So stay tuned for the press conference that will be held from 11 o'clock this morning. And there will be program manager present, and there will be an official announcement. And the press conference will also be live streamed. So thank you very much. And I would like to thank all the viewers for their encouraging words.
Sorry. So to try that again, thank you all for being here with me this evening for our live coverage of Hayabusa 2's grab and go on the surface of Ryugu. Now, while this ends today's coverage of this little mission, this isn't all this little mission has to do. There will be at least, well, there's currently planned 2 more touch and goes, although we do not know the exact dates that Hayabusa 2 will be going in and grabbing those additional samples. When that occurs, we will bring it to you live right here on CosmoQuest X on Twitch. Now, while this is all that Hayabusa 2 has to offer today, this isn't all that space science has to offer today. There's still a lot more to come. We won't be bringing you, I don't think, the press conference live, because instead we will be covering the launch of SpaceX, and it will be carrying the little lander that we hope can for the Space IL program. This rocket, it's a normal SpaceX. What more can I say? Now, Space IL, their little lander, is one that was designed initially to meet the requirements of the Google Lunar X Prize. This was a prize that was run by the X Prize Foundation and funded by Google, where companies, private entities, not government entities, were challenged to travel to the moon. Once they got there, touch down, then move by whatever means they chose. They could flit, fly, hop, hip hop, dance, whatever they wanted, 500 meters across the surface of the moon. After moving, they were then asked to send back a high definition video to the Earth. Now, we don't know exactly when Beresheet will be landing on the moon. It is first going to be going into Earth orbit and then going into a very slow and gradual set of evolving orbits, getting more and more elliptical until it finally transitions over to orbiting the moon instead. This is a slow process that will take time, but also saves them on how much propellant they need to carry and what kinds of energy they need to extend to get where they're going. Now, this is going to be brought to you by our other host here on CosmoQuest, Annie Wilson, Binary Ablaze. She's currently finishing up dinner, and I need to switch screens because I don't know what YouTube is about to play. She's currently finishing up dinner, and as soon as she is done, she will be going live here for that SpaceX launch. So stay tuned. Go take a bio break, grab a snack, grab yourself some coffee, because the science continues. I will be back in the chat when Annie goes live, and let's just spend the night together taking in all the good space exploration going on. Now, before I run the credits, I want to remind all of you that we are a production of the Planetary Science Institute working in collaboration with Youngstown State University. We are sponsored by you. We are here thanks to the generous contributions of everyday viewers, people who send us their subs, send us their bits, and allow me to help keep the science going. We aren't just a Twitch channel. We are a platform for doing science. And in the coming months, well, we're going to have you helping us find that place on the surface of Bennu that is scientifically interesting and safe to land, because OSIRIS-REx wants to explore. So stay tuned. So much more is coming, and it's all thanks to you. So thank you so much for everything that you've enabled, for bringing us your energy, your questions, your subs, your bits, and most of all, yourselves. We love seeing you over and over in chat and getting to know you. So wherever you are in the world, have a fabulous morning, evening, afternoon. Dash outside, look up, dash back in, and look online, because the science will continue. Thank you for being here. Only go away for a little bit and then come right back. Bye-bye.